I want to extend what we have got today to the transport equation. Transport equation of vorticity. Transport equation of vorticity. Vorticity, don't forget, is still here. How does it transport? Transport equation of vorticity. Transport equation of vorticity. That is diffusion. Diffusion equation of vorticity. Some people also call it, some people also refer to it as what? Diffusion of vorticity. Of course, how does it diffuse? Let us now look at equation 2, 3. Then let us look at equation 2, 3 and take its curl. To arrive at it is very simple. Take the curl of this. Take the curl of equation 2, 3, 3. So the diffusion equation of vorticity is achieved by taking the curl of 2 prime prime prime, taking the curl of this. That is, I will take the curl of this, take the curl of this, take the curl of this, and take the curl of this. But recall, that what? That curl graph is what? 0. Is 0 always. Is 0 always. Take note. We proved this in the class. In class. These have been proved. We proved this in class. So, from the class work, we are taking the curl of 2, 3. This equation, as I said earlier. So, if you take the curl of this, take curl of this, curl of this, curl of this, and curl of this. First time, second time on the left, take the curl. The whole of this is now first time of the right hand side. Take the curl and take the curl of this last one. Realizing that kinematic viscosity coefficient is a constant. Otherwise, it cannot come out of this derivative. Now, you can see that because this one depends on space, whereas this one is on time. This one can slot in, goes easily here. So this one can be written as what? This one can be written as T of what? Of curl Q. Because curl is space derivative. Whereas this one depends, so it works on this. So we are still coming back to expand this. This is curl of Q cross zeta is equal to, as I said earlier, look at this. If you apply this rule, the whole of this represent 5. Okay? Curl graph is called, the whole of this represent 5. So that means curl graph 5 is what? That is 0. Because the whole of this vanishes, we are not left with what? We are not left with see, I forgot to tell if this also operates on this. It operates on this. So this let on its own. So this is this. I mean, now we now have this square of what? Of curl what? Curl Q. Joined by the same, you can see curl. This curl operates on what is inside. This is curl of Q. as column. If this one still stand on its own, so that expression is correct. Then there is something I want you to note. Don't forget that call Q we said. Don't forget that call Q represent what? This alone represent what? The vorticity vector. Don't forget. Again, look at it here. It appears here again. It is what? It represents the vorticity vector. Therefore, we can rewrite without loss of generality the equation as positive. Again, I want to expand this. What is the expansion of this side? We have seen this today. What is the expansion of this? This is like if you have represented this one by A and you represented this one by B. We have seen it today. What is called A cross B? Called A cross B is what? What is called A cross? Okay, in the class. I have not mentioned it today. Perhaps it's part of the assignment I gave you. Recall that we have cross A cross B. It's one of the identities that I gave you in the class. Perhaps it's part of the one that I asked you to prove as assignment. That reminds you. So let us expand this. This is expanded as what? This is B dot A. Then when you interchange, it is going to be minus A B. I've explained the reason to you before that, because anytime B is operating on this, it is plus. But if it is operating on A, the second one is always minus. Then plus again, there are 4 terms. That is B cross what? B plus A dB, because this is plus. This plus is actually with this. You can see anytime you get B with this, it's always positive. Then if you now interchange, it's going to be minus what? Why? Because this negative sign is always attached with the operation of this side. With A, you can see it is also negative. But anytime that you see B and D together, anytime you see B and D together, it is always positive. But when you see A and D together, it is negative. A and D together, it is negative. Just a reminder, so that you don't need to start cramming everything. Just a way of reminding you of how to get it. Now, if you look at our equation that we are deriving, so we came across it. This is very important. It's part of what I asked you to prove. Please do it and send it to me in a week's time, not even a fortnight, because I've been with you for long. Now, I want to apply it on this. If I apply it on this, if I apply this rule on this, what do we obtain? That means that if you want to expand this. So this can be expanded as well. So if I now have this, Q is A. So that means Q stands for A and zeta stands for B. So if this were to be expanded, this now will be what? P is B. That is zeta. A is this, minus interchange then, that is Q zeta. Now this time around is plus A, that is Q, D what? D B minus B, B is zeta into what? Q. So that's it. That's the expansion. Now, this is what I want to use. I want to come and use it to replace this. But it is very important to know that if we are treating incompressible fluid, what happens to this? This is what? Yeah. For incompressible. Incompressible fluid. For incompressible fluid, the Q is always what? It's always 0. So this will destroy it. So you are left with the rest. For an incompressible fluid, that is generally 0, and also the okay. Secondly, there is also another one. Div Q is 0. Div theta. How about this? It's always what? Let me remind the watch out of what? Zeta, which is the zeta is what? Zeta is called what? Called Q. Zeta is called Q. That is called Q. Remember? But div call is what? Is 0 always. Is 0 always. Is 0 always. Is part of the assignment given to you. That is, there it was written as we said the call A or B is what? Is 0. Always is 0. So because of that, and this is vector, this is this, so that means this is also what? Is 0. This is 0. Generally 0, always. Always is 0. You can see your useful identity. See useful vector identity is there. So we have removed this, we have removed this. So what is now left out is we can now write this as what? Therefore, I can now write this simply as what? That is going to be minus of what? I can now put it inside. Minus back with it. So what is left are just these two terms. That's what we are left with. So that means we now have zeta dot del Q, okay, minus what? Minus Q del what? Del zeta. So that is the expression. So in fact, we have reached where we are going. So we can now rewrite this as, I want to rewrite this last expression as well. Therefore, so that we can write this as, what we have here cannot be written as, so we cannot write this simply as what? As di zeta di G, I mean that is this, minus times minus what? Minus zeta so then that is it. Then minus times minus, that gives us plus what? Plus Q, then zeta. Okay? The only thing left now is, on this side, this is the only term left. That is zeta, then square what? You can see in this expression, zeta overrides, that is, the vorticity vector overrides. In fact, that is the so-called equation of vorticity transport. The transport equation of vorticity or the diffusion of vorticity. But let us write it more neatly. It can be written more neatly as neatly, we can now write this as, I want to take this one to the other side. Okay? So this can now be written as, let me take this one, I will take this, I will take this, so that I can write it as di zeta by t plus q dot plus q dot what? Dot zeta. So this now crosses to join this. That is now zeta dot q plus what? Plus mu then square zeta. This is where we are coming. This is the so-called the transport equation of vorticity. Those of you who will be taking MATA 26, you are still coming. You will come across something like this in MATA 26 under magnitude by the dynamics. Where this one, we remove this, we put magnetic field. We put magnetic field. Remove this, put magnetic field. Then this place, put magnetic field. This place, put magnetic field. That is the so-called magnetic transport equation. So by second semester, by next semester, I'm sure that this will be treated. To those of you who will be offering magnet wide dynamics. Now, this is what can still further be simplified. This is, it can still further be simplified. Let me call this equation what? This is equation 3. I hope we are not calling equation 3 at all. So that is equation 3. But remember, this can be linked. You can see what you have here is the same thing as what? Because of material derivative, d dt is what? Di t plus what? Plus q. So I can throw anything here. So what we are throwing into this time around, see it is what? Zeta. 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 You can see it. So that means the whole of this can be represented by what? This is total derivative. Don't miss total derivative. We don't write it like this is different from this. It's the combination of this that it is. It's not equal to what? It's not equal to q plus. So that's also another form. It's another form of this equation. So if you look at this, that is why I call it 3 prime. Either of the two, equation 3 above, equation 3 or 3 prime is referred to as what? As vorticity. transport. Quantity transport equation. Or diffusivity or diffusion equation. What is it? I think we have tried our best for today's work. The only thing is that please submit the assignment given to you. You see, assignment, I can't remember. The assignment involving the proof of some useful identities. Okay? 1 week time. I think to the group. Is it not the group?
Yes, the group.
So I send it to the group. Then many of them will be asking me for the group.
There's a group, we'll put it on. After the link, we'll put it on the group then.
Okay.
How to should we type it?
This group,
Camera, okay.
I think, let me stop. I spent about 1.5 hours. So